All right, let's get into it. Today, we're breaking down the complete blueprint for building serverless Python functions on one of the biggest platforms out there, AWS Lambda.
So let me just ask you this. What if you could run your Python code in the cloud, whenever you need it, without ever having to manage, patch, or even think about a server?
Well, that's exactly the promise of AWS Lambda. It's an incredibly powerful tool, and in this explainer, we are going to walk through the entire process from building and packaging to deploying your very own functions.
Okay, first things first, we have to understand the fundamental building blocks. Every single Lambda function is built around a few core components, so let's break them down.
The absolute heart of your function is what's called the handler. You can think of it as the main entry point. Whenever an event happens, like a file gets uploaded or an API gets called, Lambda knows to find this one specific method in your code and run it.
And this is what it looks like in your Python code. The standard signature is just a function, usually called Lambda handler, and it's designed to take two really important arguments: event and context.
So what are these two things? Well, the event object, that's your data. It's the payload from whatever triggered your function, and Lambda's nice enough to convert it from JSON into a Python dictionary for you. The context object, on the other hand, is kind of like your backstage pass. It gives you all this useful runtime info from Lambda itself, like the request ID or memory limits, which is, super helpful for debugging.
Okay, so you've written your handler, you've got your logic down. But hold on, you can't just toss a raw.py file at AWS and call it a day. You have to package it up for deployment, which brings us to our next step.
Right, here's the deal. Lambda needs a single self-contained unit called a deployment package. And this package has to include not just your code, but also every single library and dependency it needs to run.
Now, this is a huge piece of advice, coming straight from the AWS documentation itself, and it's one you really want to pay attention to. They recommend you bundle everything, even libraries that you think might already be in the Lambda environment, like Boto 3.
And this is exactly why it's such a big deal. When you bundle your own dependencies, you avoid those weird, hard-to-trace bugs that can pop up when AWS updates the runtime without you knowing. It gives you total control and makes your deployments predictable. Now, the flip side, of course, is that now it's on you to keep those libraries patched and up to date.
Now, when it comes to actually creating that deployment package, you've basically got two main roads you can go down: the classic zip file or a more modern container image.
Let's break it down. A zip archive? It's way simpler, and it's perfect for most basic functions. But if you need a really large package, we're talking up to 10 gigabytes, or if you need total control over the operating system itself, well, then a container image using Docker is the way to go.
If you go the .zip route, the process is pretty straightforward. You make a project directory, then, and this is the key part, you use a special pip command with the -target flag to install all your dependencies right into that folder. After that, you just zip up the contents of that folder and drop your own Python script into the very top level of that new zip file.
The container approach, on the other hand, is all about the Docker file. You'll start from an official AWS base image, copy your code and your requirements.txt file in, run pip install inside the container, and then set the final command to point right to your handler. Once the image is built, you just push it up to Amazon's Elastic Container Registry, ECR, and you're good to go.
So, your code is deployed. Awesome. The next step is making sure it runs efficiently. And performance in Lambda is really all about understanding how the execution environment works.
And honestly, the number one concept you need to get your head around is execution environment reuse. See, when your function is called, Lambda spins up an environment. If another request comes in right after, Lambda can just reuse that same warm environment, which saves a ton of time and, money.
So how do you take advantage of that? Well, the trick is to initialize any heavy objects, like database connections or big SDK clients, outside of your main handler function. This makes sure they're only created once when the environment first spins up. This simple change can dramatically cut down latency on future calls and helps you crush those dreaded cold starts. That's the delay when Lambda has to build a brand new environment from scratch.
And hey, speaking of package size, if you're using the zip method, you need to burn this number into your brain: 250 megabytes. That's the absolute max for your total unzipped deployment package. It's a hard limit you have to work with.
All right, last but definitely not least, once your function is running out there in the wild, you need to be able to see what it's actually doing. And that's where logging and monitoring come in.
The really great news is that Lambda handles the basics for you.
It automatically captures all the output from your function and funnels it straight into Amazon CloudWatch logs. Every single invocation, every error, every print statement, it all gets logged.
Now, you do have a choice in how you log. A simple print statement works, sure, but it just gives you plain text. The pro move is to use Python's built-in logging library. By telling Lambda to format the output as JSON, you get these beautiful structured logs. They're way richer and have queryable fields like level and request ID, which makes hunting down bugs so much easier.
And you can go even further. Lambda gives you even more knobs to turn. You can explicitly set the log format, you can filter logs by severity level to cut down on noise in production, and you can even send your logs to a completely custom CloudWatch log group.
And there you have it. That is the complete blueprint. We've walked through how to structure your code, how to package it up with all its dependencies, how to pick the right deployment method, and finally, how to keep an eye on it once it's live in the cloud.
So with this blueprint in your hands, the only question left is this. Once you get that first function deployed and running seamlessly in the cloud, what amazing problem are you going to solve next?